How's it going, everyone? Welcome. Elder Gonzalez here. And today, let's going to now continue to explore about this particular book from Get Started in JavaScript, which is a series of books from Kyle Simpson, a software engineer that has previously worked at several companies, where now he make this particular book where the intention is for those JavaScript developers that wants to understand and want to be competent of doing this work, of understanding this and creating and designing applications or solve bugs, which is most of the time what you gotta do if you are new to this field. Well, but if you're not in point in your career where you say, hey, you know what, I need to understand how this language actually works. I need to be able to, when I go through a particular interview process, or when I need to describe something, I need to is quote is the specifications when they so for example, when they ask you for questions about how things work, so not only that you remember all of that, but that you understand what is this, you understand how the things work, and that you can point those peoples out, and not also that you understand not all the theory but also the practice of this, which is what we're gonna do kind of in this video. So what we have discussed or talk about it is the what is JavaScript and why the name in it itself. I'm not going to dive deep too much into that. This is part of the chapter 1 from this series of book, the You Don't Know JS Yet, all right? Second edition. In this first, well, it's describing is the name of the language, who made the language, why it names JavaScript, and what is the assumptions that was done by the language, and who oversees the spec, right? And who now owns the legal trademark. So you have is the Oracle, so for example, that own the trademark through a series of acquisitions, as well as the TC39, which is the group that oversees this spec, and it's a guarantee that the web doesn't break, which is part of the motto. And this group, they run bi-monthly meetings when it is a variety of peer across the web related industries. So whether it's device makers, browser makers, and so on and so forth. And this actually is lay out the rules of how the JavaScript engines, or the JavaScript engines must behave. But because the reality of the way is something that is completely different to what the spec says, because this mismatch between, well, the TC39 actually comes after the birth of JavaScript, which is the reason why we have this particularly mismatch. And some JavaScript engines can decide to say no to certain specification, which is something that you can look at the spec, right? There is a particularly appendix where they say that, and this is just for legacy reasons. There is also a common, particular case known as Mushgate, which is a very interesting comedy in drama in JavaScript community. It's quite interesting that you dive deep into this. I highly encourage you to go after that to understand what is that and how do we get here. I'm gonna give you a particular hint. The TC39 makes mistakes, and so in any case, because of this mismatch that happens not only for the TC39 but the JavaScript implementation, which is the reality of the web, this is also happens to ourselves. And because we must be aware of where environment we are developing, whether it is on the mobile browsers or on the light bulbs or servers, right? Each one of those environments is going to expose something to the language known as the host environments. And this is the fancy way to say that. And because these host environments, and you can now run JavaScript across different environments or host environments, right? The only reality that matters is the web. So everything stick to what the web says. So because also the language as move on across the years and also decades, and the TC39 doesn't want to break the web. This is part of the motto. So they provide this backward compatibility, which is kind of hard. It is quite hard. And yet it also tells you is how important it is for us to provide is this, or for the library maintainers to provide backward compatibility for certain features. And why the recommendation of using JavaScript is to use the JavaScript community is to use the latest syntax, because then you can rely on other toolings out there that is going to transform that into something that is relevant or can be understood, is widely available for all browsers. And if it's not, it's going to provide now something known as polyfill or shims, which is just simple code that now provide a particular features, right? So I will really look at how promise is included here, because that might be quite mind-bending, okay? But the thing here is, this particularly polyfills or shims are a code that must provide the feature if not supported by the host environment. All right. Or by that language at particular moment. So because you can now use JavaScript with procedure and object programming and functional programming, it turns out that we need to understand how the JavaScript engine works, and that is by looking at if this is an interpreter or a compiled language. But at the end of the day, the only thing that matters is, at least for JavaScript, or the heart of the question is that how the language is processing errors, right? So for example, for traditional compiled languages, they're going to now tokenize all of this. It's like putting all of these relevant keyword operators, identifiers, and putting all of this in buckets, which is tokenizing, which allow them now to perform some parser or syntax analysis to create now the abstract syntax tree. This is part of the compiler theory. And once you create this abstract syntax tree, now it turns it is a term to usually generate, depending on the language, but usually generate is a binary, a portable binary representation of your instructions that is be ready for distribute across that distribution, whether it is on Windows or Mac or Linux, right? But that's the core of all of this. So the idea is that because the compiled language behaves in this way, and in an interpreter language, when you want to detect a particular error, it goes through line by line until a truly interpreter language. It goes line by line until it detects some errors and then crash the program. So those errors in compile happens at build time, whereas on runtime or dynamic languages or interpreted language, it happens now at runtime. But the thing here is that JavaScript doesn't behave that way. In fact, JavaScript now is detecting for early errors. For example, some syntax errors. This is most the common one error. Before actually doing anything, before actually executing the code. So the thing here is, what happened is, when you are in UID and the JavaScript files leave UID, it's going to be passed through a tooling called Babel, which is a transpiler, which says now, hey, the current state of the JavaScript so the current reality of the web is that the vast majority of browsers are supporting is this kind of features, right? You can also see in particular website called can I run it? I think it is. Can I run it? No, but can I run it if you want to check your PC actually? Can run a particular game. No, but it's that can I use it? Exactly. Is that can I use, right? So support for HTML5, CSS3, as well as JavaScript JavaScript syntax. I think it is. Say promise. Exactly. It's also support JavaScript features. Promise.then. Or the promise.finally, right? Promise.prototype.finally actually is look into that. But the thing here is that this is the reality of the web, right? So this is now widely available. Promise.finally is widely available, similar to promise, all right? It's 95 here. The idea of this is that this particular tool is going to inspect which JavaScript files needs to be transpiled, okay, that can be widely available for all these browsers, and then now it's going to pass through a series of build process to be ready ready to be delivered. Now, once your JavaScript engines receive that, whether it is on the server or on the browsers, but when it's received that, is going to now parse that into an abstract syntax tree, and parsing here requires is some syntax errors. All right, you can also actually make some syntax errors and try to console log that to actually if a true interpreted language will have to go and analyze this one as then until we find the syntax. But this is not what happened here in JavaScript. You can actually have the certainty of that. And once it transforms that into an abstract syntax tree, which is the JavaScript engine internally now is going to take a look at a profiler and a compiler to actually generate some intermediary representation of the code, some bytecode, and doing some doing some further refinements about it. So the thing here is that once that happens, okay, then once that process is complete, then your code is ready to be executed. So this is exactly what happened in JavaScript, and this is quite important when we're going to look at other features in the language. So for example, like functions declaration and function expression, and why it is important to understand that because this is part of this way of how the JavaScript engine works. So the TLDR is that JavaScript in essence, if not in practice, is a compiled language. And because of this, and because the concern that the language is not fast enough at parsing or executing, so there has been attempts to try to prove that the JavaScript engines, at the end of the day, is a fast language, right? So for example, with ASM .js, which is they pour the Mozilla engineers back then, they pour a game from Unreal to a JavaScript using a subset of JavaScript known as ASGS, which is not meant which was not meant to be authored by by developers. But it turns out that JavaScript is powerful enough when you provide some hints to the engines to actually execute a game. Holy. So that was in 2013, and years later, then you have is this spiritual successor known as WASP, where it goes a little bit further by saying, hey, what if we want to skip the parse time here? I want to now skip is the yeah the I want to skip is the parse time. So I can now focus is on execution. So this representations of this language, which looks like an assembly, that is now is being used as this universal compiler target, because you can actually is point to a particular language, whatever application is written in that language, whether it is Java or C, C++, Rust, and then now compile that into a WASP, which is now able to be able to execute it in this WASP environment. So this is very interesting in some advanced research and R&D stuff, but the TLDR is that is recognizing that the JavaScript language, the concern about the parsing and the execution that can be slow, and how there has been some attempts and some success in that field to actually now create is this particularly languages or this intermediary language, right? Like WebAssembly. WebAssembly is not meant to be replace JavaScript. It just means to enhance now what you can do in the web, all right? So because as JavaScript developers, we need to actually make sure that we prevent some errors, okay? And the JavaScript implementators actually provide, the spec actually provides a way for us as a JavaScript developer to use the strict mode, which is there is particularly rules or practice that JavaScript that are enforced to the JavaScript developers to guide the compiler to do further optimizations, or to provide some hints to the compiler for further optimizations and execution of the code, right? So for example, when you use a strict, the value of the this instead of a function is now null, not a windowed object. So for example, and the other is that the name of the parameter, if they are the same, they're gonna throw an error. This silly stuff is just an attempt to now, as a JavaScript developers, follow these particular rules to provide some hint and guide now the JavaScript engines to be more performant when parsing or executing our code, right? So this is why we see directive in React, like use how do you call it, like use client, like use server, use strict is another one, and not only use strict actually change the semantic of the language. So but the TLDR is all of that. Now in the chapter 2, which where we are now, and I want to explore here, is that I'm just gonna do some JavaScript survey about our knowledge here. And first thing first is that each one of those programs is a standalone. You might think and you might feel tempted to think that your entire JavaScript, all of those different files that actually act as one. And the reality is that JavaScript see each one of them as a independent file, right? So this is explained because the way how now these files are processed, how actually the JavaScript code is processed, is parsed by the JavaScript engine when it comes and detects some particular errors. So you can have it, for example, several of this script in your index, and if one of them fails, so for example jQuery, all right, or Google Analytics, all right, so your applications will at best your application will work partially, okay? So perhaps you're not going to have some interaction, some nice models and pop-ups and confetti and stuff like that. But the only way that all of those standalone files act as a one is if they are communicating, if they're sharing is the state from the global scope, right? Or if one of those files, when they're exposed that, if they're exposing is internal data or methods, they also now they are now is sharing their state at runtime. So because of that, and as we move on, for example, with the ES6, when we look now at the models and how the models, as well as not only for import but also for the script type model, right? How both of them, regardless is the loading mechanism or the co-organization, right? They act, all of these files that you're importing at runtime, they are now interoperable here. So they act like a single one at runtime. But again, it is useful for us to think that every time that you see a particular file, right, it is a standalone file. So with that, okay, then we look at, okay, so how we now write applications here in JavaScript, how we started to code here. Well, first thing first is to understand what value is, where a value is now the most important unit of information that was defined by Shannon Claw, which is mind-blowing if you think about that, because now he actually create a mathematical theory about the information of this. It's like quantification of the thing. So I also love to use this example here when we say, hey, it is like try to quantify is in weight is how much pride do you have. So how much how much pride do you have, how much courage weight on you, right? How much love. So I mentioned this because there are now ethereal stuff, there are abstract things similar like information, right? But again, this is in a broad sense. This is also like, it's like, how do you quantify his emotions? You know? But again, this is part of the mathematicals, so on and so forth. Good. Now, with that, right? It turns out that this unit of information, which is now how programs maintain the state, and this maintenance or this representation, which is our their values, can have in different ways. So we have now primitive. It can be in two groups: primitive and objects. So primitive is, well, all of these different representations that we can have to maintain the state of our application, as a string or as a number, as a boolean, as a symbol, as a big int, which is recently added, as well as the symbol, which is some hidden information that you want to, or some secret data that is not going to be exposed to the JavaScript developers, right? But you can hold that. So, for example, useful for low library or frameworks out there. And also the type of emptiness, how you represent emptiness. So at the end of the day, values represent is this information. Represent is how do you can now show this kind of characters, okay, this sequence of characters, especially here in English or in Hindu or in hand-based like Chinese, Korean, Japanese, Vietnamese, Philippines, so on and so forth. And and they now follows a particular representation of that, the Unicode, which is something they're going to see that later. Similar with the numbers. So how can we now represent is these numbers? So we use is the IEEE 1754 spec that says how can we represent is 32-bit, 64, 128, and so on and so forth, and the limitations that we have in that the representation, right? So similar for booleans, what are the values, as well as a big int. We want to represent now huge collections that go beyond that number, and objects. So when you want to now represent is, for example, collections of values, okay, lists of values. So arrays, this numerically indexed collections of values that can be any type of value that we mentioned before, or also arrays, or an objects, or functions. And now how object, which is this key map, which is this key map that allow us is to, well, put is different or use now a string as a key to identify to which and map that to a particular value, any value that we can use, and that leads to also functions. And functions, which is now it open up the functional programming paradigms. So functions now is a value in JavaScript. Not all language treats values in JavaScript, and it is important for a language to treat that as a value because now it opens up the functional approach, the functional programming, and the techniques and the patterns that we can use. So this functional approach, which what it's going to attack or approach is anytime that you have a problem that requires computations or calculations, right? So this particular set of techniques are actually useful for that. But if you don't understand what is the end goal at the end of the day, it's quite hard for you to not only to understand, it's for you can memorize all of his technique, but if you don't know how to apply that, it is quite mind-bending, it is quite useless. Sort of speaking. So in any case, this is what it is, right? This is why it's important for us to understand that functions are values in JavaScript, because we can also use that values in our maps or in our arrays. Or our map, I mean, is objects, right? And they can log some other particularly powerful techniques. So, for example, like high order functions that you can pass now functions to another functions or return as another function, right? Let me stand up. So, uh, so that to me was very, it was open, why eye opening. To me, it was eye opening. Absolutely, man. Absolutely. Oh my God. When I see that, it's like, what the fuck is this? Now I understand that. uh, and that lead us is to now understand that these JavaScript functions, which are values that you can now unlock, so for example, like high order functions or dynamic, uh, uh, some sort of dynamic, the dynamic programming. All right. So hey, I want to execute this particular code when I receive this specific data. Or in other words, you can have now a map that is having all of this set of instructions, right? A map with all of this set of instructions. And then, now that you have this table or this hash map here, you can say, hey, by the time that I receive this value, and if this value match to one of this, I want to execute this set of instructions. And so on and so forth. And that's mind bending, bro. that's that's completely mind bending stuff. In any case, the whole point of this is, sorry, to look at now, understand what a function is in JavaScript, all right? So, in functions, before that, we need to look at how can we use now variables, right? How we can define variables, how can we use them, what is a variable at the end of the day, which is a container of a value, and these containers of values that it has a syntax form where each one of those has inherent behaviors. Var, let, var, let, and cons. Each one of them specifies that how this value can widespread across our entire program. Okay, how this value can be accessed through our entire program. So variables are now global or function. Now let are much constrained, where they say, hey, you can is redeclare a variable using let, but you can later on reassignment, okay, in this block, right? Where cons is more constrained than that, because it say, hey, you can redeclare. This value is available in this block, and this value that is available in this block cannot be redeclared or reassigned for primitive. However, for objects, you can mutate that. And there's some workarounds of how you can actually prevent that mutation or to create now copies of that. So for example, object.create is one of them, or yeah, this is why we later on going to dive deep into this. All right, to actually understand is this JavaScript standard building classes and methods, what to do during JavaScript coding, find out what platform you are coding and familiarize yourself. La 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 la. Make yourself introduction under a minute. This is more like when you want to be now in a particular JavaScript coding, right? Be familiar with HTML, CSS in JavaScript, and DOM concepts like this, and important concepts like data structure, as I mentioned. So algorithm, JavaScript language, data type, checking for types, type coercion, scope, closures. So again, something that we're gonna see that later on. Arrow function versus normal function, invoking functions via function prototype.apply, function prototype.call, promise, handling variadic argument, the DOM, the runtime, all right, the runtime APIs, evaluation access, and useful tips for this, right? Better practice questions, debounce, throw, array the prototype, a filter, promise at all, query, flattening, and so on and so forth, right? A comprehensible list of JavaScript coding questions, which is something that we're gonna see that later. But it's important, at least for us, to understand now how to understand the concept, the theory here. That's exactly what we're doing here. To understand the theory, I already have the practice, but now I want to actually clearly understand this. So, because here we in the functions, we also in this lexical scopes and so on and so forth, or sorry, these variables and the variables and how you can use these variables, what is the syntax form of the variables, and also how you can define variables without relying is on the these particular keywords. So for example, with functions, the identifier and the value that happen is at compile time, at parse time, unlike now function expressions, which is the value that a function that you can assign to a variable, and that is gonna be this is known as the hosting. This hosting process, oh my god, this is known as hosting. So functions declarations, they say that they're hosts, but it's because is the association between the identifier and the value of the function happens is at compile time. And here is when people don't get it about hosting. It's just a concept, but as long as that concept doesn't have any solid ground or rock solid foundation or understanding, it only works in the realms of idea, not in reality. And I figuring out that. So this is the process of hosting. so for example, so at compile time, there are several stuff that happen, and I am not quite familiar to all of them. I just only exposed to certain of them. Oh my god, here we go, bro. Oh my, Jesus, French those guys. So the association of the binding of the function name the association between the association of the function name of the function declaration name with it is value Okay, the association of the function declaration name, uh, the identifier with its value uh, happens at compile time in JavaScript. Because of this, there is this concept of hoisting. Mm-hmm. You're correct that the function declarations are hosted in JavaScript, which means they can be called before you appear in the code. This happens because during the compile phase, JavaScript engine scan for functions declaration and create binding for them in the respective scope. However, the precise mechanism is a bit more nuanced than association happens at compile time. What actually occurs is during the creation phase and the execution phase. The function declaration. Okay. Oh, and now let's get into French toast to this. At compile time, or at parse time, or the creation phase. Okay, but my question is that, okay, so is the creation phase where where in the spec can I look at the creation and execution phase description, bro? Doesn't use exact term creation phase or execution phase. Those are pedagogical terms. They have become popular in JavaScript educations. The actual spec describes this concept through several interconnected sections. For overall execution model, look at executable code and execution context. This is the main section that describes how JavaScript code is executed. Environment record describe how bindings, variable functions are stored. Private environment record. Execution context. The core concept that manage scope and execution state. The core concept that manages scope and execution state. Execution context. Okay. The core concept that manages scope and the execution state. For what we call the creation phase checks 9.111 set mutable bindings and related bindings operations. Functions declaration instantiation. This is crucial. It describes how functions and variables declarations are processed before execution. Functions declaration instantiation, and then the other is resolve binding. How identifiers how identifiers resolution work. For hosting specifically is this runtime semantics. And this is also important to understand here. The runtime semantic and the syntax. Let's take a look at this at once. Runtime semantics. Okay. The runtime semantics in section 14. Function declarations, statement and declarations. Statement semantics. Runtime semantics. Hostable declaration. generator, async and async functions or generator, hoistable declaration, functions declarations, unbreakable statement, iteration statement and switch statement, hoistable declarations. Which is on ECMAScript language statements and declaration syntax. Holy moly. Block statement, variable statement. And a statement can be is a block statement, is a variable, an empty statement, an expression statement, if statement, breakable statement, continuous statement, break statement, return statement, with statement, label statement, throw, try, and debugger statement. Okay, now it makes a lot of sense. Here is telling you is what an statement is. What an statement is in the language. Holy French, those similar to the declaration. What a declaration is. It can be a hostable declaration, it can be class declaration, it can be a lexical declaration. And what is a lexical declaration? Whether it is a let or cons, whether it is binding list. Holy moly. So things started to make a lot of sense. Okay. Hoistable declarations. Functions declarations, generation. Hoistable. What it means, hoistable? Hoistable, it means like wait, what? Meaning capable of being hosted. Yeah, but hosted? An apparatus for lifting heavy and cumbersome objects. Hoisted. But it's an apparatus that helps to lift something. In Spanish, como un ancla. In Spanish, hoisted in Spanish, sí, como una vela, izado, izar, correcto. Eso es un verbo en español que raramente se utiliza. That's a verb in Spanish that you rarely use. It has very specific context. Izar o levantar, pero izar. So hoisted, izar. There you got it. So hoistable declarations, so functions declarations, generator declarations, async functions declaration. Makes a lot of sense. Async generator declaration. This is this is revealing, bro. This is revealing a statements declaration. And here is describing is the runtime semantic evaluation. Hey, how I'm going to run this. Generation declaration, async function declaration, and async function and async generator declaration. Runtime semantic, hostable declaration, functions declarations, breakable statement, iteration statement or switch statement. So here is describing is this, right? Generation declaration. Hey, this definition of how you can declare is a generator, okay? Oh, look at this. Static semantic and early errors. Hmm. Exactly. There is a parsing phase that happens in the language that actually detects some errors, early errors, right? If the syntax error if has direct super or generator method is true, if it is a syntax error if unique formal parameters contain GIL expression is true. Oh, that's interesting. If unique formal parameter, so if I do this, holy hell, um, generator methods and class element name. So for example, if I do something like this, generator declaration and class element name. So if a function generator with its name to say, hey, this is the generator or iterator, right? And if this only GIL is true, it says that it is a syntax. If unique formal parameter, if unique formal parameter, mm, if unique formal parameter contains GIL expression is true, say GIL. Exactly. Hey, unexpected GIL here. If a syntax error, if unique formal parameter contains GIL expression is true, unexpected identifier. But stuff like that. So hey, you can have a GIL name here, for example. It's telling you that. But again, it throw a syntax error. This is what I describing is this series of stuff that happens at compile or parse time, right? Before the code is even executed. Hmm. Hmm. And remember, this is not a genuinely JavaScript environment implementation. This is a JavaScript friendly implementation. If strict formal parameter is true, the early errors rules of unique formal parameters are applied. If binding identifier is present and the strict binding identifier is true, it is a syntax error if the string value of identifier is either a val or argument. Exactly, so reserve keyword. If it is a syntax error if function body contain uses strict of a generator body is true. So for example, if you say something like this, right, and then you want to try to use strict, right? Of a generator body is true is simply parameterless. I would like to know is to generate is this error. Hey Claude. To recreate this new kinds of errors. Help me to recreate this error list. I think I wasn't clear to that. Yeah. Okay. Um, Help me recreate this error list in JavaScript so I can look at it. For example, is this or this. Oh, how is this? Unique formal parameter contains yield expression is true. Non-simple parameters. Syntax errors illegal. Use a strict directive in function with no simple parameter list. So I was trying to use this. Syntax error. Illegal use a strict directive in function with no simple parameter list. Illegal use strict directive in function with no simple parameter list. Bound names of parameter also in lexical declaration names of body. So for example, like this, syntax errors identifier. Use the eval, arguments, genome, genth. Class as super props. Formal parameter contains super call. Valid generators like this. But again, I'm looking is at this is because not for these particular errors here, but this is also something that JavaScript implementation must follow. All right, and when you look at this, this is actually a truly representation of the language in itself, right? In other words, it is that hey, this is the source of truth. This is the source of truth. From how generations are evaluated for syntax errors, and then evaluated at runtimes, right? And all of this. So this is actually explaining you how the things actually works. And it is mind bending, bro. And it is mind bending. We can use this now. Claw, ChatGPT, Gemini, whoever you like to call, to help us with this. That is mind blowing and very revealing. Similar for early errors. If a syntax error is a parameter contain yield expression if is true. So for example here, what is this? It is a syntax error if an arrow function exactly has a parameter here. If your arrow function has a parameter, yield is an error here. For example, this is an error here. Are not allowed in the parameter. Okay, holy moly, bro. Generator functions, async function as well. Okay. Class definition here. It is also telling you what are the early errors that happen here. Holy moly. It's actually, it's there. It's here. It's actually describing it in this numerical, in an algorithm numerical way, how all of this happens. That is mind bending, bro. That is truly mind bending. That is truly mind bending. Mm-hmm. And then I can use this clock if I don't understand something. Check this out here and then move on to the next one. Yeah, this requires devotion. This requires dedication. Class example one, constructor super. Exactly, because you can call is a base. You are the base class. No parent class that to call. Exactly, you are the parent class. Multiple constructor methods, of course. Or example three, private method. Private field pros must be declared only once. You know, but there is this static errors here or static semantics that in essence makes JavaScript as a compile language. In essence, make JavaScript as a compile language. Holy moly, bro. We find the truth of this. You can assign the super value to a field initializer with super. It must be in the constructor. Valid example for comparison. Class valid class extend parent. Valid calling parent method, not super. My private field. Valid private field. That is mind bending stuff, bro. That is mind bending stuff, bro. Mhm. Early error, class element kind. Class element kind is no arguments and return constructor method, not constructor method or empty. Mhm. Constructor method. Static semantics. Mm. Mm. It's a static, no constructor. Prototype name lives L private identifier valid contains arguments in this one. Class field definition evaluation. Class static block definition evaluation. Exactly, and then how is going to being evaluated this? Mm-hmm. Oh, okay. I think this is quite revealing. We're not going to dive too much time looking at this, but we now for sure. Mm, mm, mm-hmm. But now we know for sure that if for some, so there are now some there are now some there are now some stuff that cannot happen here. GL expression not allowing formal parameters, you know, and all that kind of stuff. So, all of this happening is a syntax time, it says parsing at parse time, at compile time. Okay, that was good. That was good. Now let's going to move on to what is the next stuff. And the next stuff is talking about is the the how can we declare variables, how can we use those variables, what are the formal what is the syntax form of those variables, declarations, var let var let, what we call the creation fact checks for set mutable bindings in section 9.1, mutable execution code execution. Executable code and execution context, environment records. This is the main section that describes how JavaScript code is executed, but here set mutable bindings and related bindings, function declaration instantiation, and this is described how functions and variable declarations are processed before execution. Set bindings here. Set mutable bindings, concrete method of a declarative environment record takes arguments and v a value. Okay, takes number of arguments, a string, and values ECMAScript language, and s a boolean, and returns either normal completion contained in use or throw completion. It attempts to change the bound value of the current binding of the identifier, whose name is named to the value. A binding for M normally already exists, but in rare case it may not. If the binding is an immutable binding, a type error is thrown. If S is true, it's an okay. It performs the following step. If the environment record does not have a binding for M, then if S is true, if the value is true, throw a reference error section, perform the coercion of Boolean, all right, or the transformation of that value into, or evaluate if this, if not exists, create mutable binding, or initialize unused binding, return unused. But all of this are the algorithm that happens here. An example of ECMAScript code that result in a missing binding at step 1. Function f here. And there is a functions declaration instantiation. Functions declaration instantiation. The abstract operations. The abstract operations. Functions declaration instantiation takes argument function and ECMAScript function objects and an argument list, a list of ECMAScript values, and returns either normal completion containing in use or throw completion. Func is the function object for which the execution context is being established. When an execution context is established for evaluating ECMAScript function, a new function environment record is created. And bindings for each formal parameter are instantiated in that environment record. So in the function environment record is created and bindings for each formal parameter. Exactly. And this is when it says, hey, internally JavaScript, when you pass these collections of arguments, each one of those arguments from that function parameter are now part of the environment record. Each, as you can see here, is creating a binding for each formal parameter are instantiated in that environment record. So each declaration in the function, like this, each declaration in the function body is also instantiated. Exactly. Each declaration in the function body is declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameter. If the default value parameter initializer exists, a second environment record is created for the body declarations. Formal declarations are functions, and functions are initialized. Formal parameters and functions are initialized as a part of the function declaration instantiation. But there is parameters and the functions are initialized as part of the function declaration instantiation. All other bindings are initialized during evaluation of the function body. And here is telling you what is doing as it is. Because holy moly. I don't think anybody can actually perhaps few people actually memorize this. Call the context code, strict formals, that's a lot. Exactly, because it performed the following step: call the context, running the context, and all this kind of stuff. Holy moly. And this is something that happens over and over and over and over and over and over. Doesn't get tired. Building, call, or construct. So that was very important, very revealing as well. For hosting specifically, the various early errors. Runtime semantics instantiate functions object. Runtime semantic instantiation functions object. And here is telling you what happened here. This is at runtime semantics. And there is a runtime semantics binding initialization. Initialize bound name. Okay. Yeah, because we can deviate our attention to what really is important, but I do know now where to look when you want to actually get some with the help of Claw, get some now knowledge and exercise and practice in real world examples, right? Of how the things work, or how the things actually throw errors and so on and so forth. So you have now the semantic syntax, which is where happen is the evaluation of early errors and the execution of the code. Good. So as we move on and as we explain here, when we mention about is the different places we can define is variables, right? Whether it's with let, with var, let, cons, also with functions as a formal as a function definition, as well as the with the formal definition, as well as the parameters that we can define, or the identifiers that are defined, or the variables as a parameter list, okay, or even inside of the try and catch error. But I do think this is quite interesting and revealing, because most of the time we want to have now at least a huge overview of the particular language, right? And then we look now at the functions, right? So we describe some functions and why functions here, and particularly functions in JavaScript is a broad term, because it is a function can behave like a procedure where you have this series of statements that can you have this series of statements that can be executed once or multiple times. You may provide some parameters, or you may provide some inputs, all right, one or multiple inputs, and then it may return one or multiple different outputs, right? So in contrast with mathematical or the functional programming, in mathematics, it's follow a certain rules that those functions must set by. And yes. So when you now declaring a function, whether it's a functions declaration and a function expressions, the function declarations happens, or the association between the identifier and the value happens at compile time, happens at the semantic time, or this hosting, where they describe here things like hosting. This is in class, this is in async. Holy moly. Exactly, hostable declaration here in the statements and declaration. What is a statement? We're talking about that. What is a statement and a declaration? So when you look at the functions definitions, okay, which are hostable. It has now declarations, and in declaration you say, hey, they are hostable declarations, they're class declaration, and they're lexical declarations. And lexical declarations are let or const, right? Are let or const. The class declaration is, well, as a class as well. This is the class declaration here, class expression. A class definition is always strict mode code. And here is telling you some errors or evaluation that happens here, right? So error detection, and then the class field definition evaluation. And then we have now the hostable declaration. So in the hostable declarations are generator declarations, async function declaration, and async generators here. That's something quite interesting because hostable declaration. Exactly, but it's in the statements. Like this hostable declaration. What is a hostable declaration? It can be a function declaration, a generator. Exactly, it's a declaration. It can be hostable declaration, class declaration, and lexical declaration. So this hostable declaration is this functions, generator, asyncs, and generator declarations. So when you look at this, the association between the identifier and the value happens at compile time, at parse time here. Static semantics, function body contain use string. And then some early errors here. For functions declaration. This is all of the errors here. Exactly, describing all of the particular errors here. Valid function expression. Anonymous function with super call. Valid function strict mode. Valid example comparison. This one, or this one, or this one. Valid no conflict here. Different name, no conflict. So good. So the association between the association between the parameter, but the association between the identifier and the body of the functions happens at compile time, whereas in function expression, this is something that happened at runtime. So it means that when your code now is correct with no common errors, and then when it's going to evaluate that association of the variables with the variable name and the value of the function happens at that specific line of code. So we also mentioned is that how functions allow us is to pass is the parameter of this. How functions allow us to declare some variables, at runtime. Okay. And because now functions can return is one single value or multiple, whether it's in a collection or as an object. We also look that values can be used as a. We also look that values functions are values, which means that you can use that as a function or as a value in an object as well, like this. So then we went through the comparison and equation, all that kind of stuff, yeah, right? But I do think that this specific recap of the functions, of when a functions and why a function is important why it is important for us to understand what a function does, okay, and what this function is capable of, right? Mm-hmm. Yeah, and what this function is capable of. Mm-hmm. So once you understand this, now you are. So now it is also interesting because it actually opens up truly this understanding of what the JavaScript is at the end of the day. Mm-hmm. Mm-hmm. Holy moly. Yeah, absolutely. So I do think that now, as we move on with other topics here in this particular section, when it comes to comparison and the equality and the when it comes to the comparison with equalish, and the coercive, all right, with the equality and how now equality is and it all goes through how now in other language you can identify how you're going to pass along a value or assign to, right, whether it is a copy of a value or if it is a reference of it, okay. You can explicitly now do in other languages, right? But in JavaScript, this is specified is per the per value. So primitive values are always when you pass around, when you pass down, or when you assign that, they are passed by value, right? However, which is when you create a new identifier, is passed by, so it create a new copy of this. However, for objects, since the value is the same, here you are passing is a reference to all of those identifiers or all of those variables that are being used, all of those containers, and if one of them actually change that, all right, if some function actually now change each one of those reference, then it will change the value in it itself. And there are some justifications for that. So perhaps most of it is related to memory. Okay, so hey, you want us to save now some memory here and there and yada yada yada. But in any case, but that's what is the equality, all right. And not only that, some of those equalities are not completely equal. Right? So for example, you have nan, which is not equal to another nan, all right, Or for example, you have now -0, which is not equal to, oh, it is, good. Okay, this is it. But for example, this null, right? However, there's some corner cases that, for example, this triple equality, in other words, this algorithm, this abstract operation is performing. So for example, with n, right? If a value is an n, which is not a number, not a representation of a number, so in those cases, you can use the quadruple equal to say, hey, actually verify if both of these values, whether it's a primitive or an object, are the same, right? And it say that this is false. Because again, even this now is, this comparison is identity comparison. So however, if you do something like this and define here an object 1, right, and then you say, hey, object 2 is object 1, right, and then you want to compare them, okay, and then you want to compare them, you're gonna tell you that is true. But because at the end of the day, all of this comparison is via its identity, okay, not based on its structure, not based on its structure. It's not a structure identity, it's a it's not a structure equality, it's a identity reference. It's identity equality here. Hey, are they the same? Okay, are they the same? Not in terms of a structure, in terms of its value. It is the same value. If it is, good. If it's not, get the French toast out of here. So even stringify to compare the source code, text wouldn't take into account things like closure. JavaScript doesn't provide structural equality comparison because it is almost intractable to handle all the corner cases. And then you have coercive comparison, right? Coercive comparison. And this coercive comparison is that what is doing this particular algorithm, when you use the double or the triple equal, when it comes to coerce that, and not only that, it also, anytime that it needs to coerce a Boolean value, okay, for example, like if, it coheres into a Boolean value, while as well it coheres into a Boolean value. It coheres to a Boolean value, bro. That is mind-bending stuff, bro. So that'll be all for this video. Take care. Bye-bye.